my pleasure to introduce Egor Kolpakov with a talk called on a class of functionals, the Feynman integrable in the sense of analytic continuation. You have 25 minutes plus 5 minutes for questions. You're welcome.
This report is devoted to class of some functionals which integrable on by Feynman and integral.
Maybe you make it full, sorry for interrupting. Maybe you make it full screen. Может на полный экран. Ctrl-L. Very well. Thank you.
This integral can be reduced to integral over Wiener measure. The Feynman integral means as integral on the sense on analytic continuations. In this report, this integral will be described. Let's describe the space E. Our functional integral will be given over E space. What is a space E? It is a union of space X by N. Space, the set X by N is a set of functions of which has this form. X is a sum of n fractions plus a sum Hölder functions. Also, we take some beginner conditions. On value of functions, value on Hölder function on some points. Also, we consider the mapping from space E to space of Hölder functions. This space is given by the next formula. Y on t is equals x on t plus integral on x in the square. This mapping can used for reducing to function integral to other functional integral on a Wiener measure. Functional integral on the top of this slide can be reduced to functional integral to center of this slide. The case we consider the integral is which depends on a complex parameter alpha. The case where alpha is a real parameter used on previously articles. 10 years ago. We consider this integral on the next class on functional. Where phi is a complex valued continuously differentiable function. X is a function from space E. This is a X function from space E. The main result of my report, the next theorem, given analytic complex functions and consider the next functional from function x, where x is a function of space E. Therefore, the functional integral, which given by this formula, has analytic continuation on alpha parameter to the next domain. According to this theorem, we have a definition of Feynman integral on space E in analytically continuous sense. This is a main result of this report. It's important to note that the space E it's strictly contains to space of Höngder's function. Therefore, this theorem gives a new definition of function. This definition, this theorem define the functional integral on new classes of function in analytic continuously sense. That's all. Have you questions?
Questions, please.
Может быть, вы уточните, что такое Т со звездой, который у вас участвует в формулировках?
T with asterisk is a point
Let me translate the question. The question was, what is the meaning of this T star, which can be seen on the slide?
T stars is a point of disconnection of function x. These points are not fixed.
You consider them as parameters, yes?
These points depends from function x. Function x depends of function y by these equations. Therefore, the points of discontinuously of function x depends on function y. The number of these points are finitely. Other questions, please?
Да, у меня есть еще один вопрос. Это вот на последнем у вас, на последнем экране, на последней демонстрации. У вас там есть такая функция x в кубе от единицы. Какова ее роль? Даже не функция, а число.
Let me translate the question. In equality 2, there is a function x square of 1. What was the role of that function?
Нет,
Do you
x
mean
в кубе.
this function? Do you mean this function?
Да, x в кубе от единицы.
We consider the function integral on this form on my article. Only integral on this form.
Ну, вы объясните, в чем роль этого числа x в кубе от единицы? Зачем это там стоит? Это не функция, это число.
Yes, it's number, it's not a function. We can, if we use this transformation with joint x and y, we can transform this expression, sum these two integrals and this number. We can transform it to the next form. Transform as integral of this whole expressions, сумму всех трех слагаемых, мы можем привести к такому выражению. The sum of these three terms we can transform to this term. This integral which depends on y. And this integral is used on a Wiener measure.
Ну и тогда логично в этом выражении иметь еще x в кубе от нуля, правда?
Yes, but we have the beginner's condition where x on 0 equals 0. Beginner's conditions on...
Да. Они где-то, наверное, написаны у вас.
Yes, these conditions it means.
Покажите тогда начальные условия, раз про это спрашивают. Наверное, это было в начале, на первых слайдах, наверное.
Yes, this is a beginner this is beginner conditions. Gamma on 0 is a sum of some number, which when we subtract
Да.
0 on these conditions, we will get x on 0 equals 0.
Абсолютно правильно.
Have you other questions?
Questions, please. Well, if there are no more questions, let us thank the speaker.